Today we are talking about the derivatives of the inverse trig functions. We are learning the last 6 derivatives today. Yes, it's 6, but it's the last. So the bad news is there's 6 of them. The last good news is this is it. This is it. There's no more derivatives of any functions to learn beyond this for this course. Okay? Now, how many of you remember vaguely inverse trig functions? Yes. There's a way to discuss, there's a way to write it besides like sine with a -1 power. What's the other way to write it? Arc sine, arc cosine, etc. We're going to learn how to take the derivatives of those. Actually going to walk you through how they came up with the derivative, and then we're going to use them to solve some rather simple problems. Yes, sir?
So, I just noticed that technically a way to write cosecant is just to looks exactly like arc sine. And when you use the power of the sine is to radical sine, right?
Yes and no. Okay. Let's go back to what we discussed the other day. What he was saying was, and everybody needs to hear this, and I'm saying it again so that it can be recorded. You've got to understand the difference between an inverse and a reciprocal. Cosecant and sine are reciprocals. An inverse cosecant is not a sine. Okay? Because when you see it with a -1 power, you usually think 1 over that thing. That's reciprocal. But in this case, the -1 power means an inverse. Okay? It's not the same thing. It is not the same thing. So they are not related in that way. Cosecant inverse or sine inverse means find the angle that has a sine of 1/2. Find the angle that has a tangent of 1. Things like that. Okay? So let's go ahead and start the notes. I'll show you. It makes more sense once I do a problem. Because believe me, when you see the derivatives, you're going to think they don't look like anything that would go with the sine or cosine. They really don't. Derivatives of inverse trig functions. Okay. Are we ready to do the problem? I'll give you a second to write down the title because I was running a little behind there. Okay. We're going to take a simple one, sine inverse of x. I want to find its derivative. I'm going to derive the derivative. That sounds kind of funny. And I'm going to find it in terms of x. In terms of x. Okay. Well, I don't know what the derivative of sine inverse is, so I need to turn it into something that I do know the derivative of. Okay? Does anybody know how to turn a sine inverse back into a sine? Nope, that's a reciprocal. That's not an inverse. It's kind of like you sine both sides is what you're going to do. So what we're going to do is we're actually going to take the sine of both sides. The sine of y equals the sine of the sine inverse of x. So the left side now says sine of y equals the sine of the sine inverse of x. Now what that means is find the sine of the angle that has a sine of x. Find the sine of an angle that has a sine of x. The answer is x. It's a circular argument. Find the sine of the angle that has a sine of 3. I don't need to know the angle, I just need to find the sine of the angle that has a sine of 3. It's 3. Well, actually, there is no angle that has a sine of 3. It's too big. So basically, in simple terms, sine and sine inverse cancel each other out the same way that square roots cancel out squares. Same way that ln's cancel out e's. So these two cancel each other out and just leave an x right there. The sine of the sine inverse of x is x. Okay, can you now take the derivative of that implicitly? I hope so.
Yes.
What's the derivative of sine of y? Cosine of y, which looks like cozy, dy dx equals derivative of x. 1. That wasn't too bad. Can you solve for dy dx now?
Yes.
So dy dx equals 1 over the cosine of y. But I said I want my answer in terms of x. Ugh. So here's the dilemma. If the sine of y is x, what's the cosine of y? Well, that's kind of hard to tell. If I asked you if the sine of y was 1/2, could you maybe tell me what the cosine of y was? What usually goes with a half? Square root of 3/2. Those are ones that usually go together. But in this case, I have an x, and it's not that easy to see what goes with an x. So what we're going to do is we're actually going to draw a triangle and figure it out that way. And you're going to have to dig back into the recesses of your brain to remember SOHCAHTOA. Y'all remember SOHCAHTOA?
Yes.
Okay, SOHCAHTOA is coming back. So I'm going to come over here. Going to draw a triangle in quadrant 1. Okay, because the sentence says sine of y equals x, tell me this. Which letter represents the angle, x or y? Which letter represents the angle, x or y? Okay, put in values for both of these. Okay, what usually goes right here? Not a y. What usually goes? A theta, right? Doesn't a theta usually go right there?
Yeah.
Sine of theta equals 1/2. Cosine of theta equals the square root of 3/2. So the y is where the theta would be. So that means that the y is the angle. Does that make sense? So we put y right there. That's the y. Okay. Now I'm going to come over here, and I'm going to write sine of y equals, now, in terms of SOHCAHTOA, what is sine? What over what? Opposite over hypotenuse, okay? Now, all they gave me is an x. How can I rewrite just a plain old x as a fraction? X over what? 1. So that's what I'm going to do, x over 1. So now I have a value for both the opposite and the hypotenuse. So now let's label our triangle. We have y here. Sine of y equals the opposite side, x, the hypotenuse, 1. Does everybody understand how I figured that out? Questions from anybody? Okay. Can you now find the third side?
Yeah.
How? Pythagorean Theorem. Okay. I'm going to call it a, and I'm going to come down here and do the math. So, a squared plus what side? X squared equals 1 squared. Agreed? Solve for a. A squared equals 1 minus x squared. I took the squared off the 1 just because I don't need it. So a equals, usually it's plus or minus, but because we're in quadrant 1, it is positive square root of 1 minus x squared. So this is 1 minus x squared. All right, now we have a third side. That wasn't so bad. Okay, now why did we do all this? Because I told you I want this in terms of x. Now, can you look at that triangle and tell me what the cosine of angle y is? Cosine of angle y. What is the ratio for cosine? A over h, adjacent over hypotenuse. SOHCAHTOA. So what's the adjacent side? The square root of 1 minus x squared. And what's the hypotenuse? 1. So the cosine of y is just the square root of 1 minus x squared. Do you agree with that? So now, my final answer over here is going to be dy dx equals 1 over the cosine of y equals the square root of 1 minus x squared. And there's the derivative. Now, I remember learning this in high school and saying, that's really weird. Because up until now, the derivative of regular trig functions have always been another trig function. Sine is cosine. Tangent is secant squared. Now, all of a sudden, the derivative of a sine inverse is something with no sines or cosines in it at all. But that's okay. Yes, we are. we are going to have to memorize this. Okay? Now, how many trig functions are there? 6. So that means, oh my gosh, I got to memorize 6 of these. No, you really don't. You only have to memorize 3. Okay? The other ones are just fall out from those. Okay? So, this is where it comes from. In a college calculus class, they may say, I want you to derive the other ones. So all you would do is change this to cosine inverse, for example. Do what we did here with cosine, rebuild the triangle, and get the answer that way. And you can do that with all of them. So if you ever happen to forget, there is a way to get it. Okay? But all we're going to do now is we're going to list all 6 of them, and then we're going to use them into problems. So here are the trig inverse derivatives. What I think is rather interesting, and I'll tell you, it'll be interesting I'm putting on there. I'm having total strangers subscribe to my YouTube channel with my videos on it. Now, they may be Reagan students from other classes in calculus, either AB or BC, but I don't know who these people are. I'm getting emails saying, so-and-so subscribe to you on YouTube. I don't know who they are. I'm like, okay, sure, thank you. I'm up to like 42 subscribers now.
I'll start making money.
Yeah. Now, honestly, I had thought about that, but I can't because I'm recording these videos on school time with school property. But once I retire sometime, if I, take a bunch of stuff and just re-record everything, who knows? I might do that. Because the district owns the site, I can't do it. That's just their thing. So
they could do it.
Yeah, they would make money off of me, off of my stuff. No, I'm not going to do that either. Okay, the derivative of sine inverse of u. Now, what if it's not just an x? We're just going to take it a step farther. It is equal to 1 over the square root of 1 minus u squared times du dx. Just change it to a u, but then put the du dx on the end. It's out to the side, and we'll put it on top eventually when we do the work. ddx of cosine inverse of u is negative 1 over the square root of 1 minus u squared times du dx. So, you see how they are the same, except for one's negative? This is actually easier than the regular trig derivatives because you don't change words. It's the exact same fraction except it's negative. Okay? So tangent inverse of u equals. Tangent's nice. This is the way I learned tangent. I told myself, okay, tangent is the only one without a square root. It's 1 over 1 plus u squared times du dx. The derivative of cotangent inverse of u is negative 1 over 1 plus u squared times du dx. And those two go together. Okay, sine's not bad, tangent's not bad, secant's a little bit ugly. Just letting you know, just a little bit. It's the ugliest of the three. I'm going to write it a little bit bigger just so you can be sure to see it properly. It's 1 over the absolute value of u times the square root of u squared minus 1. It's the same radical as sine except it's flipped. The terms are the other way around. Times du dx. I'm sorry? Very, very rarely. Okay, derivative of cosecant inverse of u equals negative 1 over absolute value of u, square root of u squared minus 1 times du dx. You will see these more in second semester calculus than you will in this course. Not second semester our course, second semester college. Okay, we are covering first semester calculus in this course in 1 year's time. Okay. So when you complete this course and move on to the next one, then you'll see this a lot more. Okay? One more thing I want to write out to the side. We remember that sine inverse, cosine inverse, etc. can also be written as arcsine of x. They are the same thing. The worksheet goes back and forth between the two. I think it has more arcsine than anything else. Any questions on these? I see some of you still writing. I'll wait just a minute. I need to go to a new sheet of paper to do the two examples I want to give you. So I don't want to go to a new sheet until you're done. Anybody still writing? Okay. Let's do a couple of examples. I'm going to leave these up here so you can see them. F of x equals arctan of 3x minus 2x squared. Okay? Unlike the other trig functions, this really isn't a true chain rule problem. It kind of is, but it's kind of not. What I like to do instead is to just think that anytime you have an inverse trig function, you call the parentheses u. And sometimes it might help just to write a little u above it to remind yourself how it works. We're looking at tan inverse of u. So whatever u is goes in and is squared from there. So f prime of x equals, I'm going to write this kind of big, 1 over 1 plus u, 3x minus 2x squared, squared. See how that's written? 1 over 1 plus u squared times du dx. So now the derivative of the parentheses, which would be what? 3 minus 4x. Y'all agree with me? Okay. So all we need to do is clean it up just a little bit. I will not require that you FOIL out the denominator. Actually, I would prefer it like it is. In future courses in calculus, they might. And actually, the answers on the back of the worksheet do as well. If it's 2 terms or more, you don't have to FOIL it out. If it's a single term, like the one I'm going to do in a minute, yes, you're going to need to just multiply it out. That's not hard. But now you have 1 times this 3 minus 4x, so the numerator will be 3 minus 4x over 1 plus 3x minus 2x squared squared, and you are done. Do you have any questions on this problem? This isn't too hard, is it? It's just needing the formulas and working it out. Okay, next problem is f of x equals x arcsine of 5x. X arcsine of 5x. You can't see that. There we go. This is product rule. Okay. I would like you at your table to try to do just the first step of the 1d2 plus 2d1. If you feel confident moving on to the very end, go right ahead. If you're a little bit shaky, just wait for me. We'll do. That is 5x, yes. But all I'd like you to do for sure is the 1d2 plus 2d1. Okay. Everybody stop for just a minute. Look up here. See if your first step agrees with mine. The one thing I'm concerned about more than anything is remembering the 5. Okay, so the 1 is the x, the d2 is this times 5, and then plus arc sine of 5x times 1. So the derivative now would be x times 1 times 5, 5x on top. Now, in this specific instance, since the u is a monomial, it is a single term, go ahead and multiply it out, because that's the way you will more often see it. So this is 1 minus what? 25x squared plus arc sine of 5x. And that's the answer. That's as far as you can go. I will not make you smile it because of the fact that that's different. And you don't have to rationalize denominators anymore either, remember? That's what we love about calculus. No more rationalizing denominators. Okay? Do you feel good about this? Could you do 10 of these yourself, do you think?
Yes.